Pesticide residue levels on fruits and vegetables are not uniform around the world, and understanding regional differences helps explain why the same apple or spinach can carry very different chemical profiles depending on where and how it was grown. These variations are shaped by climate, farming practices, economic pressures, and, most importantly, regulatory frameworks. When consumers compare imported and locally grown produce, they are often really comparing entire food systems, each with its own strengths, gaps, and trade-offs. In countries with strong regulatory oversight, such as the United States, Canada, Japan, and much of the European Union, pesticide use is closely monitored through registration systems, maximum residue limits, and routine testing. Produce sold in these markets, whether locally grown or imported, is legally required to meet national residue standards. Large-scale monitoring programs consistently show that most produce complies with these limits, but compliance rates and residue patterns still vary by origin. Imported produce in these regions is often tested more frequently at borders, especially when it comes from countries with different pesticide rules or past compliance issues. This can create a perception that imports are riskier, even though higher testing intensity itself increases the likelihood of finding violations. Locally grown produce in highly regulated countries tends to reflect domestic pesticide policies, which may restrict or ban certain chemicals still allowed elsewhere. For example, the European Union has phased out or limited a number of pesticides that remain in use in parts of Asia, Latin America, and Africa. As a result, local EU-grown produce often shows fewer types of residues, though not necessarily zero residues. At the same time, local farmers may rely more heavily on a smaller set of approved chemicals, which can lead to repeated low-level exposure to the same substances rather than a wider mix. Imported produce presents a more complex picture. Many exporting countries grow food specifically for international markets and must comply with the residue limits of the importing country, which can be stricter than their domestic standards. In these cases, export-oriented farms may actually follow tighter pesticide controls than farms producing for local consumption. However, enforcement and transparency vary widely. In regions with limited regulatory infrastructure or fewer resources for farmer education and monitoring, improper application, banned chemicals, or inadequate waiting periods before harvest can still occur. These gaps help explain why residue violations, when they happen, are more often associated with certain imported products rather than local ones. Climate also plays a major role in regional differences. Tropical and subtropical regions face higher pest pressure year-round, which often leads to more frequent pesticide applications. Leafy greens, herbs, and soft fruits grown in warm, humid environments are particularly vulnerable to insects and fungal diseases. This does not automatically mean unsafe food, but it does increase the likelihood of detectable residues if controls are weak. In contrast, temperate regions with distinct growing seasons may rely on fewer applications, though storage-related treatments can still contribute to residues on produce consumed months after harvest. Another factor influencing residue levels is farm scale and access to technology. Large commercial farms, whether local or international, often use standardized application equipment, precise dosing, and integrated pest management strategies that reduce overuse. Smaller farms, especially in low and middle-income countries, may lack training or resources, leading to inconsistent application practices. This does not mean small or local farms are inherently riskier, but it highlights how uneven access to education and regulation shapes residue outcomes more than geography alone. Regulatory compliance is also tied to how countries define and enforce safety. Maximum residue limits differ internationally, sometimes by large margins. A residue level considered acceptable in one country may exceed limits in another, even if actual health risk is similar. This can create confusion when reports label certain imported foods as violations, without explaining that the issue is regulatory mismatch rather than extreme contamination. At the same time, Differences in standards raise legitimate questions about global consistency and whether current limits adequately reflect long-term, cumulative exposure. From a consumer perspective, the distinction between imported and local produce should not be reduced to simple trust or distrust. Locally grown food can offer advantages such as shorter supply chains, greater transparency, and stronger alignment with domestic regulations. Imported produce expands dietary variety, improves food security, and often comes from farms that meet high export standards. The real risk tends to arise where regulation, enforcement, and education are weakest, regardless of whether food is local or imported. Ultimately, regional differences in pesticide residues reflect broader inequalities in global food systems. Stronger international cooperation, harmonized standards, and better support for farmers worldwide would do more to reduce pesticide risks than encouraging people to avoid entire categories of produce. For individuals, awareness matters more than origin alone. Eating a diverse range of fruits and vegetables, washing them properly, and understanding that residue levels are shaped by systems rather than simple labels allows consumers to navigate these differences with realism instead of fear. In this context, both local and imported produce can fit into a healthy diet, provided they are supported by transparent regulation and informed choices.